second section of this chapter 11 is the calculus of vector valued functions. So we have here a vector valued function R, yeah, which is given by its components f, g, and h. Then for this function, we can talk about limits, we can talk about derivative, we can talk about integrals, etc. So we can do various things with a function like this. For example, in terms of limit, if you have a function, a vector valued function here, you want its limit as t approaches 0, then you just substitute, just as you will find a normal limit. So the limit will be a vector, obviously. So what will be the limit of this function? It will be 1, yeah, 5 cosine 0, which is 5, and then sine 0, which is 0. So like this. That's basically the limit of this function as t approaches 0. Do you understand this? Yeah. So just normal limit, but with 3 different functions, f, g, and h. Here's a second example. We want to find the limit of this function. If you substitute, the first component will give you 6. Second component, minus 3. The third one, undefined. 1 over 0, we don't know what it is. So basically this limit does not exist. Because of 1 over t, this limit does not exist. Yeah. Because the limit of 1 over t as t approaches 0 itself does not exist. The other components are fine, but because this one has a problem, so the whole thing, the whole limit does not exist. Does that make sense? Yeah? No problem. Okay. Continuity, of course, you know the idea of continuity of a function. Function is continuous if it's at a, yeah. If its limit is equal to its value at a, yeah. This is the idea of continuity of a function. You should have done this in Calculus 1, of course. A lot of continuity questions there. So here, determine for what values of t the vector valued function is continuous. Okay, so let's look at the different functions. The first one, f, e to the power of 5t, is continuous. This function is continuous for all values of t. It's okay. This function, continuous on the whole interval minus infinity to infinity. No problem. It's continuous, it has a derivative, everything. The second function, len of t plus 1. What can you say about this function? What is it continuous? Yeah. Basically, you know, for a len function, the t plus 1 must be greater than 0. You must have that. Otherwise, the function is not even defined. Therefore, t must be greater than minus 1. So this function is continuous on the interval from minus 1 to infinity. And the third function, of course, the cosine function, is continuous everywhere. You know, this graph is like this. So it's continuous on the whole set of real numbers from minus infinity to infinity. So in the end, what can we say about R then? Where is it continuous? From negative 1 to infinity, like this, because of the middle function g. So we can say the conclusion of this is that R of t is continuous on the interval minus 1 to infinity, like this. So that is the conclusion. So you look at basically the smallest interval, the intersection of all the intervals, like that. Okay. Now, the derivative of a vector valued function, so you have R of t here. Well, its derivative is just the derivative of f and then g and then h. So if you have R of t like this and you want the derivative, then so it's going to be cosine t squared, but you need to multiply by the derivative of t squared, which is 2t. So we start with the 2t cosine t squared, and then the second one, negative sign. Where does the negative sign come from? The derivative of cosine t, and then e cosine t, and finally the t ln t, you need to differentiate it using the product rule. Yes, you need to use the product rule here. So it's going to be ln t plus, can I put 1? T multiplied by 1 over t. So it's going to be 1, huh? Can we put 1 directly? This 1 is t multiplied by 1 over t. Right. So that's the derivative of R. Very easy, no issues there at all. Okay. Yes. The other thing we need to mention now is, so you can see some rules when you want to work out the derivative. If you have R plus S, then it's just the derivative of R plus the derivative of S, and so on. You can use the product rule also. If you have F multiplied by R, etc. So we have different rules. Now, the other thing I want to mention here is that if you have R of A, which is a vector, then the derivative R dash at A is also a vector, the black vector here, and it is tangent to the curve of the end points. So it's R dash is the tangent vector. So the tangent vector to the curve C at the point corresponding to t equal A is R dash of A. Okay. So here, for R of t equal to this function, By the way, if you graph the endpoints of this function, x and y, you can see that it's going to be a circle, because x squared plus y squared will give you 1, yeah? X, y, if you square both, you add, it's going to be 1. So actually the endpoints are a circle, yeah? The blue circle here. Then r at pi over 4, if you try to find it, so it's going to be minus cosine 2 times pi over 4 and sine 2 times pi over 4. And this will give you 2 times pi over 4 is pi over 2. Cosine of pi is 0, yeah? And sine 1, exactly. You can see that here, the vector r of pi over 4 is 0, 1. So it goes 1 along the y-axis. Now, the r dash, yeah, and draw the position vector. It's okay. This is the position vector. That means r, yeah. And the tangent vector is, what is the tangent vector? The derivative, yeah, r dash. So first we need to find r dash. It's going to be the derivative of r. So minus 2, sorry, sine 2t, or plus, yeah? Because derivative of cosine is minus. There's already a minus there. So it's 2 sine 2t. And the derivative of sine 2t is 2 cosine 2t. And therefore, at pi over 4, substitute, it's going to give us 2, yeah, 0. And you can see it here. The 2, 0 is the vector which is, because y is 0, so this vector is horizontal. Can you see y equals 0 here? And how long is the vector along the x-axis? 2. You can see it's twice as big. This vector tangent at this point, and it's twice as big as this one. So twice as big. Like that. Yeah. Okay, let me just. Okay, finally, I'll just complete this. You can find an integral of a vector valued function by integrating each one of these. So it's the vector, no, integral now, yeah? We're integrating. Can you see the integral sign? So what is the integral of t squared?
T cubed over 3.
Yeah, t cubed over 3 plus 2t plus a constant, let me call it c1. And then the sine of 2t, yeah, it's going to be minus half of cosine 2t plus another constant, which we can call c2. And finally, the third one, this one, what is the derivative of this t squared? 2t. So you can think of this as 2 and then 2t e t squared, like this. Now this 2, take it out. And then what is the integral here?
E to the
E to e, yeah, t squared like this. Yeah? I think I mentioned this many times, that if you have u dash eu, then this is just eu. Yeah, very important rule. So therefore, what you have here will be 2e t squared plus another constant, c3. So that is, in the end, the whole integral is here. Do you get this? Yeah. So you integrate each component of this vector, you get another vector, which is basically the integral of the vector you started with. Finally, we can find the definite integral like this from 0 to 1. So this will be, yeah, okay. So it's going to be the integral from 0 to, so let's calculate each one separately if you want. So you will have sine pi t dt, its integral from 0 to 1. So this will be 1 over pi minus 1 over pi cosine pi t. Is that okay? Or no? Yes? From t equals 0 to t equal 1. Now, if you substitute, I think it's going to give you 2 over pi. So let me give you the answer. You can check it, yeah, no problem. Then we need to have what's the second thing we need? The integral of 60 squared plus dt from 0 to 1. So this will give you 2t3 plus 2t squared, yeah, from 0 to 1. And you substitute, it's going to give us 4, I think, yeah. So that means, so I can then say that the integral from 0 to 1 of the function, the vector valued function, is equal to the vector 2 over pi 4. That's it. Like this. Does that make sense? Yeah? So that is. So basically, what we are saying is like a vector valued function R, you can find its derivative if you want, which is also a vector. You can find its integral, indefinite integral here, the indefinite. What's the difference between indefinite integral and the definite integral? Yeah, without boundaries. Indefinite is without the boundaries, so it's going to be a function of the variable, whatever it is. Here it's t, so it's a function of the variable t. Whereas a definite integral is here a vector. It's actually a value of a given vector. So you can find the limit of a function, vector valued function, and so on. After that, it's very simple. So let's maybe just have a look at some of these quickly. What will be this limit, girls? Negative 1? 1?
Negative 1, then 1, 0.
Yeah,
0.
and 0. Yeah, very easy, no problem. Negative 1, 1, 0. Okay. This one,
doesn't exist.
Ah. It does exist. You know what why it exists?
They're all valid.
Yeah, they're all valid. What's the derivative of the first one? Sorry, the limit of the first one?
It was a rule, I think it was equal to 1.
Yes, I think you must have seen this in Calculus 1. It's a very famous rule, identity, the limit. This is always equal to 1. This is a well-known result from Calculus 1. So if you want this limit, then it's going to be 1, and then 1, and then negative 1, like this. So it does exist. This one, on the other hand, does not exist, because ln of t, as t approaches 0, really does not exist. So this limit, yes, we can say does not exist. Okay. Let me just maybe do 7 and then perhaps finish with this example 7. Where is this function continuous?
All except t equal to.
Yeah, t equal 2 is a problem, yes? Because of the first one, yeah? So the first one, t plus 1, t minus 2 is continuous, except everywhere, except at t equal 2. So t equal 2 is a problem because of the first function. So we need to exclude it. Second, the second function, yeah, t squared minus 1 must be greater than or equal to 0. Otherwise, we have a problem. Now, what is this greater than or equal to 0? Well, there is a way of doing that. You may solve it equal to 0. That will give you two values, minus 1 and 1. And then you need to check the regions. Between minus 1 and 1, if you put, for example, 0, you can see that this expression is going to be negative. For t greater than 1, it's going to be positive. For example, 2, you can see that it's going to be positive, also positive on this side. So therefore, yeah, so square root of t squared minus 1 will be continuous on the interval from minus infinity to minus 1, and also from the interval 1 to infinity. And finally, 2t, of course, is all. Yeah, 2t continuous on the whole interval minus infinity to infinity. So when we put all of this together, that means, what is the 2? Well, 2 is here, yeah? We need to take it out. That means this function r is continuous from to minus 1, and then from 1 to 2, and then from 2 to infinity, like this. So I can write the final answer is r, yeah, of t is continuous on minus infinity to negative 1. We can include negative 1, by the way. And then union 1 to 2, exclude 2, yeah, and then from 2 to infinity, like this. And that's it.
So why -1 and 1 belong to the, why do they belong to the interval?
Sorry?
Why do they belong to the interval?
Which one?
-1 and 1.
Well, I mean, you can think that this function is actually continuous at -1. You can exclude it, that's okay, but you can also include it. It's continuous from the left at -1. If you graph this function, yeah, it will be at -1, say, it will be something like this. At -1, it reaches the point -1. Yeah. So you can think of it as being continuous at -1.
Also because greater than or equal.
Yes, because there is no, this function, t squared -1. Can t be equal to 1 here? Can you put t equal 1 here? Yeah, you can, yes. 1 minus 1, 0. Square root of 0 is 0. It's fine. It's perfectly okay. So this function, but if the square root of t minus 1 was in the denominator, it will not, you have to exclude the 1. You understand it? Like this. Okay then, girls, thank you very much for your attention. And I hope you have a nice day. Any questions at all? Anything you want? Yeah, it will be very similar to that, yes. So just questions, if you can do them, you will be fine. Okay?